All right, guys, just a quick video for those of you that weren't here to learn the lesson for 4.3, or maybe we just went a little bit too fast in class and you want to see it again. First of all, remember, as you're watching this video, there is a pause button. So if I'm talking too fast or if you need a minute to write things down, pause the video, rewind when it's necessary. That's the benefit of having the video to access is you get to go through the lesson at your pace, whether it's faster or slower than what I was doing in class. So 4.3 is all about solving equations, which you know how to do. You've been solving equations. You've been doing the railroad track thing since probably 6th grade. And you followed a lot of the same steps that we're going to use today. So the problems today, the difference is this right here. There's going to be a square with the x. If that was just 3x minus 27 equals 0, you could solve that in 15 seconds. But this year, we're not just solving equations that are straight lines. Remember, our equations are parabolas, and we want to find the solutions to those equations. So, a couple examples here that you want to put in your notebook. 3x squared minus 27 equals 0. We want to solve that. So I'm going to do railroad tracks because I want to move everything away from the x. So the first thing I need to move is the 27. So I'm going to add 27 to both sides to get 3x squared equals 27. Then I'm going to divide by 3, and that gives me x squared equals 9. Now here's where the new stuff comes in, right? You should be able to get to this point really easy because you've been doing it for years and years. Now I've got to get rid of a square. And the way that I do that is by taking the square root of this side. And that makes the square go away. But if I do that to the left, I have to square root the right. And here's where things get interesting, because on the left-hand side, all I'm left with is an x. But when I take the square root of 9, I get 3. But earlier in the year, we talked about the fact that there's actually 2 answers to that question. When I take the square root of 9, I'm looking for 2 numbers that multiply to be 9, but it has to be the same number, right? So 3 times 3 equals 9. That's why we get this 3 right here. But negative 3 times negative 3 is also equal to positive 9. So when I take the square root of 9, I actually get 2 answers. I get a positive 3 and a negative 3. So when I write my answer, I'm going to write x equals 3 and x equals negative 3. And the reason that's happening, just to show you really quick, this function is, if I were to graph this, it's shifted straight down about 27 places, right? And it's a parabola that goes up. So the reason I have 2 solutions is because of these 2 points right here. I cross the x-axis twice, which means I have 2 solutions. Positive 3, which is right here, and negative 3, which is where it crosses on that side, all right? All right, example number B. Let's look at what happens in this one. Solve x squared minus 10 equals negative 10. When I do my railroad tracks, I'm going to add 10 to the left. I'm going to add 10 to the right. So I get x squared equals 0. My 10s went away. They canceled each other out. So to get rid of that square, I have to square root, and that makes it go away. But I have to square root the right-hand side. Well, when I take the square root of 0, I get 0. And in class, a few people wanted to say, well, you also get negative 0. Guys, negative 0 is not a number. That doesn't exist. X equals 0 is going to be your only answer, okay? And what that means for the graph, the reason you're only getting one answer, which is kind of hard to imagine because our shape is a U. So how is it possible that it only crosses X once? And the reason that happens is because your parabola is sitting right on the x-axis. So it doesn't cross it and then go back up. It just, my parabola comes down, it touches x, and then it goes back up. So I only end up with one solution, and that's x equals 0. Now part C, something else happens. This is x squared solutions are weird because it's not always the same thing. We had two solutions in the first example. We've got one solution in the second example. In the third example, when I take my railroad tracks and I minus 11, I get negative 5x squared equals 5. So I've got to divide by negative 5, which gives me x squared equals negative 1. Okay? Now, to get rid of the square, I square root. That makes this go away, and I have an x on this side. But when I take the square root of negative 1, when I plug that into my calculator tells me this: no real solution. Which doesn't sound like an answer, but that actually is our answer. What happens if I try to take the square root of a negative? That's impossible. I can't do that. There is no such answer. So there is actually no solution to this equation. When it says solve, I can't solve it. There's no solution to it, all right? And the reason that there's not a solution, if I look at the graph, this graph looks like this. Oh, where'd my pen go? This graph looks like this. It's below the x-axis. The x-axis is up here. But my parabola comes up and then it goes back down, but it never reaches the x-axis. It never crosses it. So there's no solution because it never touches the x. So I have 3 different possibilities on the homework problems today, okay? And your textbook has a really good little diagram of those 3 possibilities. I'm going to copy that diagram, but I'm going to write it in my own language. And you can write this however you want, but it is probably something you want in your notebook, okay? So if I take the square root of a positive number, we're gonna say D is a number, okay? If I take the square root of a positive number, that means I'm going to end up with 2 different solutions, okay? My graph is going to cross in 2 different places. If I take the square root of 0 when I'm solving, that means I only am going to get 1 solution. It's not always going to be x equals 0. It could be something else, but I'm only going to get 1. And if I take the square root of a negative number, that means I'm going to end up with no solutions. As soon as I take the square root of a negative, I can stop right there because I know that I'm not going to have any real solutions. My graph is never going, the graph still exists. That's the thing that gets confusing for some people about this example C. This graph exists. This equation exists. They're real, they're functional, they work. They just don't have a solution. They don't cross the x-axis. But there's a lot of good equations in the world that match that don't cross the x-axis, but they're still equations that work, okay? So that doesn't mean that the equation is broken and messed up and there's a problem. It just means that the graph is never going to touch the x-axis. That's all that means to get no solution, all right? So make sure this is written down in your notes. If you need to pause the video, pause the video. All right, let's do some examples, okay? We're going to do all 6 of these because some weird stuff's going to come up that you haven't done before with solving these equations. So number 1, negative 3x squared equals negative 75. In fact, it might be a good idea. Pause the video and go ahead and try number 1, 2, and 3. Don't try 4, 5, and 6 yet. You'll make a mistake. But try 1, 2, and 3, and then hit play, and let's see if you did it right. All right, so for number 1, you would do railroad tracks. Then you would divide by negative 3. So you end up with x squared equals 25. Then you would take the square root of both sides, which makes the square go away. So you get x equals, I'm taking the square root of a positive number. So I'm going to get 5, and I'm going to get negative 5. Those are both answers. So I'm going to get x equals 5. x equals negative 5. Number 2, you railroad track. You minus 12 from both sides. You end up with x squared equals negative 2. Then I've got to take the square root. And right there, I already know I'm going to have an issue. I'm not even going to type it in my calculator because I know what my calculator is going to say. It's going to say, you tried to take the square root of a negative. You're not allowed to do that. There's no solution. Actually, it's just going to say no real solutions. Okay, number 3. Railroad tracks. Whoops, sorry, my screen's rolling around. I add 15 to both sides. 4x squared equals 0. I divide by 4. X squared equals 0 divided by 4 is just 0. If you don't know that, type it in the calculator. It will tell you. Then I need a square root, both sides. That goes away, and I end up with x equals the square root of 0, which is 0. And since I took the square root of a 0, that is my only answer. Okay? All right, 4, 5, and 6. Some funky stuff happens, okay? We get a few weird scenarios. And here's kind of the basis of solving these problems. And it all depends on what teacher you had in middle school and intermediate school, because they all taught this a little bit different. But what's happening is in all 3 of these, there are parentheses. So when I'm solving an equation and there's parentheses in it, I have to be really careful about the order that I solve things in. If you had Mrs. Walker at the middle school, she would have told you, to circle what's connected to the x. So the x plus 7 and the x minus 3 and the 2x. She would have had you circle those things. And then she would have said, that you get rid of last. Everything else you have to get rid of first. If you had Mrs. Ledbetter, she would have said, normally we have to follow PEMDAS. But when you're doing railroad tracks, you actually do PEMDAS backwards, all right? Whatever they taught you, Mrs. Oldroyd would teach you to get rid of the parentheses by distributing what's in front of it. Now, here's what all of those have in common, okay? In this first example, I have a parenthesis. I can't make it go away by distributing because there's a square. This is the new part. I've got a square on the outside. What you need to remember is you are not allowed to touch anything inside the parenthesis until everything on the outside is gone. I can't touch that plus 7 when I'm doing railroad tracks until I get rid of everything on the outside. So I've got to get rid of that square first because it's on the outside. So for number 4, the first thing I'm going to do is take the square root because I've got to get rid of that square. So that means I'm going to square root the right-hand side. So on the right-hand side, square root of 0, that's easy, that's 0. On the left-hand side, the square goes away, so all I'm left with is my x plus 7. I don't need those parentheses anymore because everything on the outside is gone. So my next step would be to minus 7. Whoops, that's a 1. Minus 7, x equals negative 7, which matches our pattern. I took the square root of 0, right? I took the square root of 0. That means I should only end up with one answer, and I did. X equals negative 7. Okay, let's look at number 5. I need to get rid of everything. I've got this x minus 3 on the inside. I cannot touch that yet. I've got to get rid of everything on the outside. I've got to get rid of this 4 and this 2 before I can touch that minus 3. So I'm going to do my railroad tracks. And now I've got to look at the outside. The 4 and the square. Which one of those do I get rid of first? Well, if I'm doing PEMDAS backwards, that means I'm supposed to get rid of multiplication before I get rid of an exponent. So I'm going to divide by 4 first to make that go away. So I've got to divide by 4 on the right-hand side. So on the left-hand side, I've got x minus 3 squared equals 9 over 4 is 2.25. If you put that in your calculator, you get 2.25. All right, I still can't touch this because there's a square on the outside. So let's square root both sides. That goes away, and I'm left with x minus 3 on the left-hand side. But on the right-hand side, I took the square root of a positive number. I took the square root of 2.25, which means I'm going to get two different answers. I'm going to get 1.5, and I'm also going to get negative 1.5. Okay? So I've got two different answers because I took the square root of a positive. On the left-hand side, though, I'm not done. And this is where railroad tracks get weird, because on the left-hand side, I have x minus 3. On the right-hand side, I don't just have one number. Now I have two numbers that I have to deal with. So when I add 3 to get rid of this minus 3 on the left, I have to add 3 to both of those numbers on the right. So I'm going to get x equals 1.5 plus 3 is 4.5. Negative 1.5 plus 3 is positive 1.5. So I'm going to add the 3 to both of those numbers. So I get two answers, x equals 4.5 and x equals 1.5. And this follows my pattern because I took the square root of a positive number and I ended up with two answers, which is what we said should happen. Okay. All right, number 6, 2x plus 1 is on the inside, so I'm not allowed to touch that yet. I've got to get rid of that square on the outside first. So I'm going to square root the outside because there's nothing else on the outside. And that's going to make the square go away. So on the left-hand side, I've got 2x plus 1. On the right-hand side, I took the square root of 36, which is a positive number. So I get a 6, but I also get a negative 6 because I took the square root of a positive. In the past, you guys were able to ignore this negative answer, which is why your teacher never really even taught you that it existed. In this class, we can't ignore the negative. It's very important to what we're doing with quadratics. So we have to acknowledge that it exists, even though it's kind of weird to have two answers. So 2x plus 1, I'm going to minus 1 on the left to make that go away. But when I minus 1 on the right, I've got a minus 1 from both of my answers. So I get 2x equals 6 minus 1 is 5. Negative 6 minus 1 is negative 7. Now I've got to divide by 2 on the left to make the 2 go away. On the right, I've got two different numbers that need to get divided by 2. So x is going to equal 2.5 and negative 3.5. So those would be my answers. X equals 2.5 and x equals negative 3.5. And again, that follows my pattern. I took the square root of a positive number and I ended up with two answers. All right, let me show you one more example because this one caused some panic in class. Anytime you guys get decimals, you automatically assume that you did the problem wrong. News for you, the real world is not just 1s, 2s, and 3s. There are lots of ugly decimals when you're doing math in the real world. So this problem, 4x squared minus 13 equals 15. You can just watch this one. When I solve this, I'm going to do railroad tracks. I'm going to add 13 to both sides. So I get 4x squared equals 28. Then I'm going to divide 4. X squared equals 7. Here's where things get weird. Because when I take the square root to get rid of the square, I've got to take the square root of 7. And when I take the square root of 7, I do not get a pretty number. I get 2.6457 something. It goes on and on and on and on. Which means I also get negative 2.6457 on and on and on and on and on. Now, in my class, we've talked about decimals. And I like you to handle decimals a certain way. When you get decimals, that doesn't mean you did it wrong. Your answers are allowed to be decimals, but I want you to always keep 3 numbers after the decimal. Every single math problem that we do, you're going to keep 3 numbers after the decimal. Everything else, you can just ignore. So your answer for this one would be x equals 2.645 and x equals negative 2.645. That's how you would answer that question, okay? All right, so for the homework, we're going to skip the story problem. We are going to also adjust this a little bit. What I want you to do for the homework is numbers 3 through 31, and I want you to do the odd numbers. So 3, 5, 7, 9, 11. If you want more practice, do the evens as well, but you're only required to do the odds, 3 through 31.